Let us master calculus with Anil Kumar. Explore the playlist with hundreds of examples. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and posting excellent questions. Here is a question from one of our subscribers on related rates of change. Now, these are very difficult applications sometimes to work with, and this particular question is extremely difficult. Provide an example of fractional function of the form y equals to ax squared plus bx plus c divided by x minus d. Write derivative of your function. Find the two horizontal asymptotes to your function. Now, when we have a scenario where we have a quadratic function in the numerator and a linear function in the denominator, it is not necessary that you may have two horizontal asymptotes. Secondly, the complexity is that if you take any function which is quadratic over a linear, you might have horizontal asymptotes. However, the point at which the horizontal asymptote exists may be an irrational number. In that case, working out the details might be slightly difficult. And therefore, selection of the right function is kind of important in this particular case, especially if this is part of your assignment. Now, what I did was, after trying some, I got a function which is simple and straightforward, and I hope that will help you to get a fine result. So, the strategy was that keep it simple. When we are given ax squared plus bx plus c, I want to keep ab as 1 itself, right? So that we have a simple function to work with, right? So the function which I chose was x squared plus x plus 3 divided by x minus 2. Now it suffices the requirements. We have a rational function which is being set as fractional function in this particular question. And we have quadratic over a linear. First step here is to find the derivative of the function. So we can apply the quotient rule to find the derivative. What we get is the denominator x minus 2 whole square, and in the numerator we have derivative of x squared plus x plus 3, and we're going to multiply that by x minus 2. Now derivative of x squared plus x plus 3 is 2x plus 1, so we'll multiply this by x minus 2, and then we are going to subtract derivative of the denominator times the function itself, which is x squared plus x plus 3, right? So at this stage, what we have done is that if we have a function f of x of the form u over v, in that case, what is the derivative? Derivative is basically equal to derivative of u times v minus u times v derivative over v square. So this quotient rule has been applied. Derivative of 2x square, x square plus x plus 3 is 2x plus 1, right? So I hope it makes sense. Now, we can actually open and simplify this. What do we get? We get 2x square minus 4x plus x minus 2, and this is minus x square minus x minus 3 over x minus 2 whole square, which is equal to 2x square minus x square is x square minus 4x plus x is minus 4x. Minus 2 minus 3 is minus 5 over x minus 2 whole square, right? So that becomes the derivative, right? So we got the derivative in a simplified form, and now we are going to do the second part of it, which is find the two horizontal tangents to your function. Horizontal tangents means that the derivative is 0, right? And we have a quadratic term in the numerator, which is x squared minus 4x minus 5, right? So let's go to a fresh page and write down the derivative for the function, which is x squared minus 4x minus 5 over x minus 2 whole square. And we are going to equate it to 0, since what do we need in part B is horizontal tangent, right? Perfect. That means that the derivative is 0. And clearly, it also means that the numerator is 0. So that means x squared minus 4x minus 5 equals to 0. You can factor this, right? You see that? So that is the ease with which we can actually solve this particular problem. And we get two values. One is x equals to 5 and the other one is x equals to minus 1. So basically, at x equals to 5 and x equals to minus 1, we have horizontal asymptote. Now, what do we need to do? We need to find the y value at these points, correct? So what was the function? So let's write down the function which we took. We took the function as equal to x squared plus x plus 3 over x minus 2, correct? So in this function, let me put the value 5. So what is f of 5 equals to? F of 5 will be 5 squared plus 5 plus 3 over 5 minus 2, correct? Which is 25 plus 5, 30 plus 3, 33 over 5 minus 2 is 3, which is 11. And what is f of minus 1 equals to? So minus 1 square minus 1 plus 3 over minus 1 minus 3, correct? Which is 3 over minus 1 minus 2, which is minus 3. Let me do the correction. Minus 2, which is minus 3, right? Which is minus 1. So we get the points also. That means we have horizontal tangents at the point, let's call this as A, which is 5 and 11, and the point B is at minus 1, minus 1. Is that clear to you? Once we get the points, the equation of horizontal tangents will be what? We need to write down the equation, right? Find two horizontal tangents to your function. So the horizontal tangents will be the y values, right? So y equals to 11 and y equals to minus 1 are the two horizontal tangents, right? You see that? That is how we are going to answer this particular question. This is probably the simplest solution to the problem. You could have started with a general equation. In that case, there was too much of work to be done. So working out a great equation helps. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.